Thank you. We're happy to be here. I'm Alex Porter, CEO at ModTech Labs. At Mod, we are focused on optimization and quality assurance for real-time content. And today we're going to talk to you a bit about unlocking efficiency with distributed processing. This is Tim.
Hey, I'm Tim Porter. I'm CTO at ModTech Labs, and I spent my career in video games and movies. In video games, I was a technical artist, and in movies, I was a pipeline technical director. I really do like making sure that artists enjoy using tools. I like to make sure that as well, it just doesn't take forever. And so that's why we're here. We're actually talking about how do you go ahead and do distributed processing appropriately, lower budget, higher budget, everything in between, and then how do you actually work in if you're doing AI algorithms distributed processing. So we're going to take it off. Alex, you want to take it away?
Absolutely. So, over the last few years, we've worked heavily in film, we've worked in XR, and Tim's background is in games. And so, we have seen sort of the broad spectrum of applications, uses for content, and processing. And we're here to share a little bit of that knowledge with you now. Wait. So we want to talk about what is distributed processing, right? I think we're all familiar with processing as a whole, right? We love our GPUs, CPUs, RAM nodes. We have to have them to function every day in our jobs, no matter what we're doing most of the time. And so ultimately for us, we look at distributed processing as a way to maximize efficiency by allocating the processing across different systems and units to the most efficient compute. So if you have some extra CPU or extra GPU, extra RAM sitting on a system and it's idle, because you're in a linear process, A to B, B to C, C to D. You're not using your systems to the best of their capabilities. Ultimately, taking that content and pushing it through the system in a way where it is moving along its path in a nonlinear fashion is actually the most efficient.
Sure. Who here's used a render farm? Yeah, we've got a bunch of people in the audience. Awesome. So render farms are really great. And they're a very low level concept of what is distributed processing. You have a single frame that goes, you have another frame, it goes, and you can do it where it's sitting in a queue, where it waits and goes doot, 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 straight down because you have a single node, or you can distribute it across all of the different nodes that you have, multiple servers, multiple systems. But if you really start getting down in deep, you can do parts and pieces based off of the power of those systems. So I have a GPU enabled system. Cool. I'm going to send this process over here to that GPU enabled system because it's a GPU enabled process. But what if we talk about things like CPU enabled? Same exact thing. And so you can really do some very amazing things where you can take things out of flow and start moving them around to where you're actually using everything at almost 100% efficiency all the way throughout the beginning to the end of your processing capabilities. And we're going to talk more about that as we go along.
So I think, one of the themes here at Siggraph that we're seeing is that there are a lot of industries represented, right? We're looking at everyone from car manufacturers to retail to film to television and beyond. It's really important to understand that we're starting to embrace the same technology underneath all of these industries. And so creating the way that we can actually solve these problems consistently for everyone is a huge deal. So I'll give you an example where we've actually worked with an oil and gas company where they are going into the field and actually scanning large terrestrial areas, right? So topographical mapping using 3D scanning. What they're using it for in real time is to actually have geologists, environmentalists actually check that the area is safe for them to do their business. And so ultimately, what that means is they need that feedback as fast as possible. And so things like distributed processing are a real necessity when you're dealing with large amounts of data and you're ultimately looking for almost immediate feedback on what you're doing. And we see that every day in film and television. We want that immediate feedback. We want to understand when we're on a shoot, what's happening, what can we see, what can we affect? And these are some of the tools to get us there.
Yeah, absolutely. And that was actually a really interesting use case because it alone, as far as just processing the mesh, was 1.2 terabytes worth of RAM. And so what we actually had to do was separate each one of those little subsections and then process those individually. That allowed us to go ahead and end up doing even more segmentation, not just on the individual asset level, but on the individual processes that each one of those assets went through. So of course you go through a meshing process. From the meshing process, then you end up going through an optimization process, includes things like decimation and then as well as texture reprojection and texture cleanup. We also have some AI that goes inside of there that does things like secondary maps. So as you start doing optimization, you need to put that back in so that it still continues to look like what it had originally looked like. And so all of those things, so you're looking at, it looks like this, but if you think about as a rack of servers, you have one here, one here, one here, one here. As this one's finished, the process that was finished on this one can go up to that one and go down to this one. And so you end up thinking about this in more of a stacked flow and across process, so you can go ahead and make some really amazing advancements and changes into your infrastructure and pipeline as you go along.
Yeah, cumulative, content processing is a massive boon for anyone that is trying to deal with large amounts of data. Anytime that you can make sure that your systems are running the entire time and fully embracing the power that you have, the more effective you're going to be and the faster you're going to get that data out. You want to start with this
So
one?
some opportunities and shortcomings. I'll start with some opportunities. And this is really amazing. We talked about some of it, and that's how you go ahead and you speed up your processing and things like that. But going back to our last project, if we think about that 1.2 terabytes, a system that can hold 1.2 terabytes of RAM, that ends up getting into the $50 to $60,000 category. But if you end up splitting that up as early as possible and say you only need 256 gigs of RAM, that can be a much cheaper $10 to $15,000 solution. So even though you're splitting up the cost and you're like, in the end, I'm spending almost the same amount, you end up getting 8 to 10 times the amount of processing power that you can distribute across. If, say, a node goes down, it's not that big of an issue. You go 7 times faster instead of 8 times faster, and that continues going across. But now let's talk about the shortcomings. The shortcomings, obviously, this sounds like it's a much more complicated process. How do you deal with the management of the nodes? Obviously, you have more nodes. That means you have more infrastructure. How do you deal with the networking that's on that? Actually, there's a lot of really good solutions that are out there. Things like Airflow are built to go ahead and help with this entire distributed processing. So you have this thing called a scheduler that actually handles where the data goes from one server to the next. And that way you don't actually have to, inside of your head, go, well, I have to go from this computer to this computer to this computer. You can put different things like weightings. This is a GPU enabled system. Let's send it to that. This is the capabilities. And it allows for your queue to fill up and to make sure that you actually utilize the correct amount of servers and systems as you move along.
There are also opportunities to take that processing data and actually use it to train an algorithm to speed up processing as a whole. So you take all of this information, the more data you have, the more powerful you can be, right, with your training. And so ultimately, we've been able to do some tests and some training that sped up our processes from an hour to 5 minutes, right? There are massive, massive gains to be had if you're able to use the systems and efficiently deploy it in that way.
So this is a fun one. How does distributed processing help enhance the capabilities of AI? Now, there's a couple of different ways that you can deal with distributed processing when you're talking about AI solutions. A really good example is TensorFlow's Lightning. TensorFlow Lightning allows you to go ahead and separate your models a couple of different ways. You can either go ahead and do where you're like, oh, my model doesn't fit in VRAM, which is your video memory. Let's split it up between all of the different video cards that we have. And then you can also do a multi-box solution where you're like, oh, instead of just this one server, I have 12 servers with that same tile of GPU. That's amazing. So to give you an example, when we use that, we actually have some GANs that we generate, and the GANs that we do end up creating things like secondary maps. So we have a diffuse that goes to albedo, albedo to specularity, fun things like that. On a single box, on uh, 4 high-end GPUs. Trying to remember the name of it. It's one of those days. It ended up costing us 6 weeks to go ahead and do the processing. Tesla GPUs. That's the word. So it ended up taking us 6 weeks to go ahead and do the processing. We actually were able to go ahead and split that up between 6 boxes. And so instead of 6 weeks, it was about a week and a half. So massive wins and massive gain that can end up happening if you're managing your own infrastructure. As well, if you start getting into some of these large language model data sets, if you're moving that direction, all of that's not going to fit into a single GPU. How do you split that up? That's same exact with the Lightning solution. It'll end up helping you with that. So, yep, next one. Ooh.
Challenges. Okay, so we manage our own infrastructure.
Wow.
So not everyone has the pleasure and pain of doing this. There are lots of different opportunities out there to run your processing. Of course, for us particularly as a small company, we'll get into the small company side of it a little bit more in a second, but. It was a big deal for us to make sure that we were cost efficient as we were actually doing this. So the challenges were deciding between running cloud, running our own infrastructure. That in and of itself is a debate that every company has to have to some extent. Is it hybrid? Is it not? We ultimately decided that running our own infrastructure was the way to go. That means we also need to spool up an entire other team of people, right? Now we need DevOps. Now we need people on site to actually do the administration of the servers. There's a whole other sort of bag of things that we took on when we decided to run bare metal ourselves. That being said, we also saved ourselves 7 times the amount of money it would have taken us to process on cloud. We have been able to overcome some of these challenges by going backwards in regard to the actual spec of the systems and distribution has actually allowed us to use older systems that wouldn't necessarily be capable of running these types of data or these large data sets. And we can now do it more effectively and efficiently because we have a lot of older systems that are more cost efficient for us, but the data is spread across the systems. It's a very interesting sort of dichotomy.
Yeah, it's kind of a weird concept because a lot of people are like, oh, well, you need all these super amazing advanced systems and you have to spend tons and tons of money. Actually, when we launched this company, we were able to go ahead and get 2 full racks of servers. So a rack is, it's about 6.5 feet tall, and most servers are, 1U, 2U. These were 2U units, so they're only about that tall worth of servers for about $50,000, all full with Tesla GPUs, everything across the board. And so you end up paying a little bit more in things like power, but when you go to a data center, that's what they cover. And so you have to spec out your data center, you have to spec out your networking, and these are all those extra little things that you just never think of when you go, I go cloud, cloud go burr. Other than that, you kind of have to, right? Other than that, you kind of have to sit there and think about things backwards. Where are we going to deal with data? And for us, because we were doing this as dual purpose, we're not just doing training, we're also doing processing. When you think about, okay, let's walk this concept backwards. I have more servers. Okay, cool. I'm now going to distribute my processing. Cool. Now I'm going to go ahead and deal with my data this way. That allows for you to go ahead and see these infrastructures as much more flexible systems. And that was some really amazing thing that we really enjoy doing. And as you can tell, I get kind of hyped about it. I really do like splitting up data and how do we make things go faster. So that's us.
And we talked a little bit about this. How can small teams get involved with distributed processing? I mean, you can run servers in your house. Should you? Highly questionable. Been there, done that. It's very loud.
I still have PTSD incident and like hear like fire alarms and like
Or
things going off. I'm like,
yeah,
the
he's like,
UPS
the
is going,
UPS.
go, go, go. Like, yeah.
Like it's a legitimate commitment. We have had many variations. We had a server rack in our house with
Yep.
like full of servers. We've had individual servers spooled up, and then we migrated everything to a data center a couple of years in, and I was like, oh, that's what quiet sounds
Yeah.
like. So there's ways to sort of get your hands dirty, and I mentioned already, but I think it's really important to understand that the distributed processing is empowering in a lot of
Yep.
ways because you can get those servers that are a few generations back. We actually are at the point now where we are spooling down one of our data centers because it is now irrelevant.
Yep.
We're like, that's how far back we went when we started. This company is 4 years old, and we went back a few generations, and now we're like, okay, these can no longer do anything.
Yeah,
Um,
we went 12 years old on our
yeah,
initial servers. They ran
yeah,
DDR3. We're up to DDR5 now.
yeah.
We had Tesla GPU. Yeah, I have some laughter in the back, and it worked. It
It
works
worked. It
great.
worked. We,
But I mean, you have to
yeah,
think this was like a huge. We're sitting there going, "Oh my God, can we get all of these servers? This is going to be great." Because we were
yeah,
we were going from a whole bunch of desktops that are all like sitting together to okay, let's get some servers and like maybe some enterprise
yeah.
with the desktops that are all still starting to go. Hey, let's go to a full infrastructure that is professional grade. And I can tell you, as much as everybody's like, "Oh, that's terrible," I haven't lost a single one of those servers.
No.
They are now
Once they're up, they
16
are
years old.
up.
They can drive in most states.
Yeah.
And they're
Yeah.
still running that data. And that's great. And that's something to really think about, especially if you build a fully distributed processing system. You can do the same thing with your storage as well. Stuff like Ceph is phenomenal for that. Longhorn's another one. That means you can take all of your storage and you can separate it all across all of the different hard drives. I can lose hard drive here, here, and it doesn't matter. It continues to go. And that's really amazing.
Yeah.
It saves it in triplicate. Really cool solutions.
One comment I'll make on this front is that we have also had some challenges in hiring because
Yep.
we are running our own infrastructure. A lot of people these days that are into infrastructure are very much in cloud land.
Yep.
And so, dealing with like real bare metal servers is a very different ball game. And so ultimately, we're finding, of course, with the sort of push into hybrid, that we are seeing it sort of swing back the other way. I look at it as a pendulum, right? Pre-pandemic, we were very much like this, especially film, television, like very much like on-site, on-premise. We run our own infrastructure. That's it. We went straight cloud during pandemic, and then now we're seeing this like sort of hybrid mix between. But ultimately, I think that it really depends. I think there's a method to the madness and understanding where the wins and the losses are for your team size, your team composure, and ultimately what your goals are as you're processing.
Yeah. So one thing, as the person who implemented these servers and had to train people on what's going on behind the scenes, I would recommend anybody, if you're going, well, let's go ahead and let's start implementing distributed processing. Look at what the cloud providers are doing. Go ahead and do things like Ansible, do things, like Puppet. Just go, hey, this is something that they understand. So that way you can hire a standard DevOps person and they're like, I got it. This is what they're doing there. There's a slight difference. You got to manage a little bit more, but that really does help solidify and broaden the individuals that you can end up hiring.
I think this actually leads us to our next slide, which is about cloud computing. So, cloud computing, as I mentioned already, there's a lot of coming to the middle, right? Coming to a hybrid solution. Ultimately, what we're also seeing in the market right now heavily is a lot more GPUs on the cloud market. That was one of the big hindrances that we had when we were looking at that as a solution, 4 years ago, even a year ago, to be real.
Absolutely.
GPU instancing was really hard to come by and really unaffordable. And we're seeing that go back the other direction now. There are a ton of opportunities and options out there in the market these days. NVIDIA has, partnered with all of the cloud providers, to my knowledge, to allow them to have that access that they need, so that we can actually functionally use GPU in the way that it's needed in
Yeah,
the
not,
industry.
not only was it something that wasn't cost efficient for us, there were many times, even with us doing the distributed processing where we were chopping things up, that we could not get cloud instances that had high enough RAM with GPU capability at the time that we started our company in 2020. And so there are a lot of really good options that are out there. AWS is a good one, Azure is a good one. Any of the big names are going to have phenomenal solutions. And there's some very specifically M&E related ones, some around the corner and things like that, that are really good solutions. And they're trying to meet us where we are. Infrastructure doesn't have to be horrible and painful and not fun. You can do some of it locally, and you can burst up into the cloud with the stuff that you don't actually want to purchase. And I think it's a really amazing time and a really amazing world that we're starting to push forward. And I think all of you guys should try to get into distributed processing. Go out and have fun.
Email Tim.
Email Tim. What? I'm not going to answer all the questions. I'll try. I'm not that good. I think
And
it's the last
that
one.
is it. Do we
That's
have any
it.
questions?
Hmm.
Thank you. Thank you.
I'm trying to be helpful.
Sure.
So you initially built your own servers, mostly probably because of the cost of being able to build it yourself.
Yeah.
At what point do you essentially see, for a small team that's trying to build out, rather than getting the really old tech, where does it just make sense to go to a cloud provider to just get everything rather than trying to manage your own stuff?
Sure.
What is kind of that threshold? Because it's kind of a sliding scale.
It is.
But where do you kind of see
It depends on how repetitive your process is. If your process, like for us, because we're doing distributed processing and we're doing pipeline and pipeline processing, I have a very quantifiable result as to what I'm looking to get done in the end. And for us, because I knew the group of individuals who was doing our processing at the time, I could go ahead and go, oh, well, this is what I'm doing, and this is how I'm doing it, and this is how I'm going forward. And so if you have a very variable process and pipeline, like today I'm doing AR projects, and tomorrow I'm doing VR, and then next week I'm going to do this other thing, and you're like up and down and up and down, there's no reason for you to go ahead and purchase your own hardware and solutions. The other thing as well, like I was very lucky, like my world, I'm not gonna date myself. Do you remember Circuit City? I was a fire dog. That was like Geek Squad before Geek Squad existed. So like my ability to go ahead and deal with server infrastructure and things like that go way back. And I actually ran my own render farm in college with older tech. Well, we'll go back. But so if you don't have that, people like me cost a lot of money. That skill isn't something you just build up overnight. And I made a lot of mistakes along the way. Like I can't say that enough. It's not today we're gonna go ahead and do this kind of process. And so that is that tipping point. There's two different things. It's the individuals you can bring on board, their skills, talent, and capability, and if they've worked, enterprise grade is a totally different thing. Even though you're doing desktops, they're different toys. And then as well, what your variation as far as the projects and processes that you're running through. If you're stable and you can find some people that want to come on board, that's a perfect win-win. It can be one or the other. The people is the harder part, I would say.
The thing I'll add to that too is data size.
Yep.
Right. Data egress is really expensive.
It is.
It's really expensive. And that for us was a hard stop.
Yep.
And that was where most of our cost was actually going to come from, because we were working with massive data sets, like
4 or 5 terabyte in.
Yeah.
Yeah.
And so ultimately, the type of project matters. As he said, the consistency of sort of the work you're doing, but also what kind of data you're working with.
Mm-hmm.
And if you're working with like tiny incremental data and it's just pinging, great. Let it ping 1,000,000 times. It's not going to cost you $1 million. If you are working with very large data sets, that is where it gets very cost prohibitive to go cloud. And yeah.
We've done certain projects where the egress alone costs more than purchasing the server just to do it locally. Yeah.
Yeah.
That happens.
Yeah.
And
We're like,
that's
all
not
right,
hard
we'll
to
just-
find either. You
we'll
can
just
start
buy a
doing the math
server,
and
it's
look at
fine.
those numbers and things like that. It's all publicly available. So, yeah. Any other fun questions? Questions,
Any other
comments,
questions?
concerns?
All right. Yeah, great. All right. Well, thank you both for coming by.
Dad jokes? I can
Yep.
tell dad jokes.
They're actually